I work on the Earth's crust, the history and evolution of the Earth's crust, where it came from, how it formed, and specifically we work in mountain belts, ancient mountain belts such as the Appalachians. So we work all up and down the Appalachians, in the Great Smoky Mountains and Blue Ridge. I've got students doing projects. We're sort of focused in central New England, but if you follow the Appalachians up across the ocean, they end up in Norway and Greenland. So I've also worked in Greenland and Norway. It's all part of the original mountain belt that formed roughly 300 million years ago. We can look at really small things. We can image very small mineral grains, features in rocks, very small fossils, and we can also determine their chemical composition. So that's what distinguishes it from a regular electron microscope. The irony is that, me and my students work on mountain belts. We work on the scale of continents, but then we analyze tiny little mineral grains that might be 100 microns across. But each of those mineral grains has in it the history of that mountain belt. This current grant is, in short, the nickname is hot granites, and you would think, well, aren't all granites hot as magmas? They're molten, they should be 800 degrees centigrade. Well, we're talking about unusually hot granites, and so for the crust to get so unusually hot requires very special conditions. What we're looking at is zircon, whose composition records the temperature of the magma. This is a project that's a collaboration with a colleague at Syracuse University. Samantha Burke is a graduate student in our department, and what she'll do is use this instrument, the electron microprobe, and another type of ion probe at UCLA to analyze those little tiny grains and tell us something about, more specifically, about the temperature of those granites. We have to prove that there were very hot crustal conditions then, but then we have to come up with a very large-scale model for why a certain part of the crust was exceptionally hot in Earth history. And so, from Earth history context, it's interesting and is compelling, but from a more practical aspect, these types of granites are granites in which ore deposits occur, and so we use ore deposits for all of the materials we have in our society. And so there is some practical application to it, but admittedly it's a pretty basic research question, but that's what a lot of us do in science. Every morning you get up and you're excited about learning something new. So sure, I don't mind sitting here for an interview, but I'd rather be in this lab collecting more data, putting the information together for a publication, which is what I was doing when you came in. Being a faculty member is being a lifelong student as much as it is anything else. We go into the high schools to try to get the best students who will then come to UK and be outstanding students, who will then go on to be graduate students and professionals. So it's just like recruiting in sports. That doesn't mean that you have to be brilliant to be successful. Some of my best graduate students have been really hard workers, and they came to UK, we kind of took a chance on them, and they've been very successful because they worked so hard.